We have been told for decades that clean code makes software better. But what if the primary consumer of your code isn't a human, but an AI? And what if making it too clean actually hurts its performance? The anxiety is real. Are you wasting time refactoring solely for readability while degrading efficiency for the tools doing the heavy lifting today? We need to settle this with data. The answer comes from a controlled study by Sonar Source researchers Priyansh Trivedi and Olivier Schmidt, published as RxIve 2C04-C149. They didn't rely on anecdotes or single examples. Instead, they ran a minimal pair experiment involving 6 different codebase pairs where the only difference was static analysis violations and cognitive complexity. One version of each repository was clean, adhering to standard readability rules. The other was intentionally messy with high complexity scores. Across 660 distinct trials, they tested coding agents on identical tasks using both versions. The results challenge our deepest assumptions about what makes code machine readable. First, the success rate for solving problems showed zero difference between the clean and messy versions. Agents were just as likely to fix a bug or add a feature in the messy code as they were in the pristine version. This proves that agents do not need human-centric aesthetic quality to understand logic. They can navigate complex structures, find errors, and implement changes regardless of whether variable names are perfectly descriptive or if functions span 50 lines without comments. However, while cleanliness did not change an agent's ability to solve a problem, it drastically changed how efficiently they got there. This is where the engineering trade-off becomes critical for your workflow and budget. When agents worked with cleaner code, token consumption dropped between 7% and 8%. In the world of large language models, tokens are currency. Every extra word you ask an agent to process costs more money in API calls. That reduction might seem small on a single task, but at scale across thousands of CI/CD cycles or heavy inference tasks via agents, cleaner code directly translates to significant cost savings and faster iteration loops. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The impact was even more pronounced regarding how the agent navigates your repository. The study observed a 34% reduction in file revisitations when working with clean code. This metric is telling us that messiness forces the AI to waste time rereading or correcting context. When structure is optimized, the agent understands the relationships between files and functions faster. It spends less time guessing where a definition lives or why a function behaves unexpectedly because of hidden side effects in poorly organized blocks. This leads us to a crucial nuance that often confuses practitioners. There are tools and arguments suggesting that agents prefer semantic density over readability, implying we should strip away comments or simplify logic too aggressively for the machine's sake. Some repositories warn that strict adherence to human-centric rules can degrade AI performance if it removes necessary context. But this study suggests a middle ground. You do not need to sacrifice structure or make code cryptic to satisfy an agent. The goal of simplification must be preserving exact behavior while reducing the cognitive load required by the machine, not just making it look pretty for a human developer staring at their monitor all day. The shift here is in how you view your KPIs. Developers often treat refactoring as a vanity project or a checkbox exercise to satisfy style guides. In an agent-first workflow, this perspective needs to evolve. We must stop viewing code cleanliness as merely about beauty and start treating it as a performance optimization for AI agents. Messy code is not just harder for humans to read, it forces the machine to waste tokens on disambiguation. Every unnecessary line of complexity or every ambiguous variable name adds friction that the agent has to overcome, burning through your budget in the process. Consider the implications for system design and career relevance. In an era where coding agents are becoming primary consumers of code, a developer who can write structures that minimize token usage becomes a force multiplier. This is no longer just about following style guides. It is about understanding LLM economics as part of your engineering judgment. You are designing systems not just for human maintenance, but for machine efficiency. The agent acts as both the reader and the writer, so providing it with high signal context without aesthetic fluff allows it to operate at peak speed. The evidence shows that we do not need to choose between writing code humans can read and code machines can process efficiently. We simply need to recognize that the cost of messiness is higher than previously thought. The 34% reduction in file revisitations proves that structure matters deeply for machine navigation, even if logic remains intact. By optimizing for this efficiency, we reduce the friction between human intent and automated execution. So how do you apply this? Stop asking, "Does this look good?" Start asking, "Will the agent waste tokens on this variable name or function structure?" The future of engineering isn't just about writing code, it is about optimizing for the machine that writes and reads it alongside us. We must accept that clean code is a strategic asset, not just an aesthetic preference. It reduces costs, speeds up development cycles, and ensures our AI tools operate at their full potential without getting bogged down in avoidable complexity. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.